All right, this video is going to cover hopefully number 9 through 15, the answers to Specimen Paper 1, the 2014 release for the IB Math Studies exam. I'm using a CAS calculator on my screen, but you're not allowed to use a CAS calculator on the exam, so just remember that. I won't use any of the CAS features on the video. All right, let's go into number 9. I've already done 1 through 8 on different videos. So number 9 is a calculus question. It says consider the curve y equals x squared. Write down dy dx. Nice simple question. So we just want to write dy dx. It means take the derivative of the function, bring the exponent down in front, and decrease it by 1, so it becomes 2x. The point 39 lies on that curve, so let's find the gradient of the tangent to the curve at that point. Finding gradient means use your derivative function and plug in the x value. So if we take dy dx and plug in 3 to it, we're going to do 2 times 3, and the gradient is 6 at that point. And we're going to find the equation of the normal to the curve at point P. So we need a point and a slope if we're going to find the equation of a line. We have a point because it's on P, goes through P rather, so 3, 9. And we have a slope, we just calculated a slope in B. Knowing that it's a normal it's asking us to find, we have to do the opposite reciprocal of that slope. So the tangent line would have a slope of 6, the normal line will have a slope of -1/6. So we want to fill in to y equals mx plus c, the point that we have, which was 3, 9, and the slope that we have, which is the opposite reciprocal of 6, because it says normal, right? Normal and tangent perpendicular to each other. So simplify this and solve for c. Let's see, -1/6 times 3, so 9.5 is c. And so you can write your normal equation as y equals -1/6x plus 9.5, or some version of that, 9.5, 19/2, whatever works for you. Okay? Consider the following statements about a quadrilateral. Got a Q statement, got an S statement, a little logic question here. Express in words the statement S, arrow forward Q. So we have an if then, right? This symbol means use if at the beginning of your antecedent, and then in the middle, and then follow it with your consequent. The antecedent here is S. So if ABCD is a square, then ABCD has 4 equal sides. Okay? Haven't changed anything, just putting it in the correct order with an if then. Don't use the word therefore. In this case, you're going to get only the full marks if you have if and then, and if your antecedent and consequent are in the correct order. Part B wants us to write down in words the inverse of that statement. All you need to do for an inverse is remember which one it is. So we've got inverse, converse, and contrapositive. Converse is the one where you switch Q and S for each other. That would be switching the antecedent with the consequent, and that's a converse. An inverse means negate the statement that you just wrote, making both of them be negative. So I'm going to come down here and write it so I have a little more room. Don't change the order, just negate it. So if ABCD is not a square, then ABCD does not have 4 equal sides. All right, there's our inverse. And then determine the validity of the argument in B and give a reason for your decision. This is one of the cases where we don't need to use a truth table to determine the validity, though you can if you want to. In some simple cases, we can determine validity just by actually reading the statement and deciding if it's logically sound or not. And we know squares and we know the rules about squares and quadrilaterals, so we can actually determine if we just wrote a valid argument or not a valid argument. So let's read it and think about it. If ABCD is not a square, then ABCD does not have 4 equal sides. And of course, this does not necessarily have to be true, because there is such thing as a rhombus, which has 4 equal sides and yet isn't a square. So that's going to be my reason for my decision. So I'm going to say that it's not valid. My reasoning is that ABCD can have 4 equal sides and not be a square. For example, it could be a rhombus. And that's a sufficient explanation without drawing a truth table and having to say that it is not a tautology. All right, we have a financial math question. We are investing 5,000 euros at an interest rate of 6.25%, compounded monthly. So we're going to find the value of the investment after 3 years. We can use the formula straight from the formula booklet. We get credit for filling in the formula correctly, and then credit for evaluating it correctly. So to fill in the formula correctly, the future value in the account is going to equal our starting amount, our principal, 1 plus the rate over 100 times the number of times it's compounded each year, which is going to be 12 because it says that it's compounded monthly. And the exponent is going to be the number of times it's compounded times the number of years. So if it's 3 years multiplied by 12, our exponent will be 36. Just note, I've seen this mistake before, you want to write this as 6.25 if you're going to include the division by 100 in the formula. Alternatively, you could write it as 0.0625 if you don't include the 100 in the denominator of your fraction, right? Because 0.0625 has already been divided by 100. You don't want to divide it by 100 twice. So points for just filling in that formula correctly, we'd go to our calculator and evaluate that and figure out that the final value, future value, is $6,028.22. Oh, it's not dollars, sorry, it's euros. So 6,028.22 euros. The other way you could do this is using the financial solver on your calculator. And you just have to fill in, the present value as a negative number. Your interest rate is 6.25. Your end value would be 36, right? The number of total times it's compounded over the whole 3 years. And your PY and CY would be filled in as 12. It's easy enough to use the formula, though, so I would just use the formula for this one. The difference in the final value of the investment if the interest was compounded quarterly at the same rate. So now we're going to calculate the final value of the investment with a quarterly compounding instead. So our future value would be 5,000 multiplied by 1 plus 6.25 or 100 times 4, right? Quarterly compounding means 4 times a year. The exponent would be 3 times 4, which is 12. And we do this on the calculator and figure out that this value, the final value at quarterly compounding, comes out to 6,022.41 euros. And it was asking us for a difference, so you could get some credit just for having this number shown. And then we'll subtract this one. I should probably subtract the bigger one minus the smaller one. So 6,028 minus 6,022. Really, I should be using the unrounded versions, but I didn't take the time to do these out on my calculator. If I was going to take the unrounded versions, this would come out to 5.80. If I use my rounded version, it comes out to 5.81. And the answer key says that I can accept 5.81 as long as both of the previous answers were correct and rounded correctly. This one is all in euros as well. So there's the difference. All right, a child's toy has a hemisphere on the bottom, a cone on the top, and those two lengths are both labeled right on the picture. We're going to calculate the length of L, which is the slant height of the cone, very simple Pythagorean theorem. In fact, well, I guess it says calculate, so we're going to want to show our calculation for that. We're going to do 5 squared plus 12 squared equals c squared. 169 equals c squared, and 13 equals c. So 13 centimeters is L. Calculate the area that's going to be painted red. This is a surface area question, and you just have to think about the surfaces that are actually going to be painted. The actual physical circle that is right here is not going to be painted because it's internal to the toy, right? It's inside the toy. We are going to be painting all of the side of this hemisphere and around the edge. Whoops, just slid that picture across the screen. And we're going to be painting around the edges, right, of this round part of the cone all the way up to the top. So we're going to be painting 2 surfaces. Let's go to our formula booklet and come up with the formulas that we want to use for two surfaces we're trying to find. So a hemisphere is a sphere that's been cut in half. So if you go to your sphere formula for surface area of a sphere, you're going to have that area equals 4 pi r squared. The radius of our circle is 5. So if you were to fill this in, it would be 4 times pi times 5 squared. But what you have to realize is that we only have half of a sphere here. So instead of doing 4 times pi times 5 squared, you should be cutting that in half and using 2 times pi times 5 squared. Okay, which is going to come out to 50 pi if we leave it in terms of pi for now. And that's going to be the hemisphere. It is half of a sphere. And then we have the cone. Now, the only part of the cone that is going to be painted red is the curved surface of the cone. And the formula for the curved surface of the cone is given to you right in your formula booklet. So the curved surface of the cone is going to be a pi times a radius times a slant height, pi r L. We have the radius as 5. We have the slant height as 13, as we just calculated in part A. And so this comes out to 65 pi. So we're going to add these two together. 50 pi plus 65 pi would be 115 pi. And if we're going to give our answer to 3 significant figures, go over here and add a calculator page. We're going to do 115 multiplied by pi, control enter, and it's 361 centimeters squared for the total surface area. So the most common mistake there is either to use a volume formula, which you want to be careful of. It's not volume when you're painting something on the outside of it. And the other common mistake is to calculate the area of that circle, which you don't need because it's internal to the shape that's being painted. All right, a mathematical model here. A liquid is being heated. They give us a couple of points, right? After 20 seconds, it's 25 degrees. After 50 seconds, it's 37 degrees. The temperature of the liquid at time t can be modeled by this function. Capital T stands for the temperature, and lowercase t stands for the seconds. So using this model, one equation that can be formed is 20a plus b equals 25. How do they get that? Well, 20a would mean that they plugged in 20 for this t value right here, plus b equals 25, which would mean that they plugged in 25 for the temperature. So they took the first time and temperature, plugged it in to the formula that is stated, and got 20a plus b equals 25. They're asking you to use the model to write down a second equation in terms of a and b. So we're going to use the second piece of information given 50 seconds, 37 degrees. So that will end up being 50a plus b equals 37. So plugging in 50 for time, 37 for temperature. Using your graphic display calculator or otherwise, find the value of a and b. Well, we're going to solve the system of equations. It says we can use our calculator, so I'll remind you. There's plenty of ways to do it on the calculator. Let's see, here I can just go to, well, maybe we want to use a graph to do it. So I'm going to add a graph. Oh no, I don't want to use a graph to do it, because then I would have to get these in terms of y and x. I'll add a calculator page and do it via the algebra tools on here. So underneath my algebra tools, a lot of these are CAS tools, but the solving systems of equations can be done on a non-CAS calculator. We're solving for 2 equations. The variables we're solving for are a and b. And now I'm going to type in 20a plus b equals 25. And you might find it's faster to just solve these by hand using the elimination method. But in case you wanted to remind yourself how to do this on a calculator, we type in our 2 equations, we hit enter, and it solves a and b for us. Value of a is 2/5, or the exam would accept 0.4, and the value of b is 17. All right, use the model to predict the temperature of the liquid 60 seconds after the start of heating. Now the model was this. The A and B that we just found are constants in the model, no matter what time you plug in. And it's asking us to find temperature when we plug in the time 60 seconds. So we go to our calculator, 0.4 times 60, add 17 to that, and it's 41 degrees, units for Celsius here, and that's the temperature after 60 seconds. All right, example 14, looks like another calculus question. I'm going to write down f prime of x. They give us the f of x function up top, so this should be pretty simple. 3 times 5 is 15, write f prime of x. 3 times 5 is 15, x to the second power, decreasing our x 1 by 1. 5 times 3 minus 15, x to the fourth power, decreasing our x 1 by 1. And the plus 1 at the end has no x with it, so the derivative of that part is 0, goes away. That's our answer. 2 marks for having the derivative, right? Find the equation of the tangent to the graph at 0.13. So remembering for an equation of a tangent, you want to use y equals mx plus c. You need a point and a slope. A point we have, 3, 1. A slope we don't have yet, but we can use our derivative really quickly, plugging in 1 to find what is the slope of that line, or what is the slope of the curve, which would be the same as the slope of the tangent line, at 0.1. So when we plug in 1 into our derivative function, f prime of 1, it's going to be 15 multiplied by 1 squared minus 15 multiplied by 1 to the 4th, and 15 minus 15 is 0. So that's interesting. Our slope there is 0. It actually tells us something pretty interesting. If the slope there is 0, then it's a minimum or maximum point. But we'll finish finding the equation of our tangent line here. We're going to plug in the 0.13, so 3 for y, 0 is our slope, 1 for x. This obviously is going to go away. The c value is therefore 3. And so the equation of your tangent line would be this, but it looks strange written like that. Much more common to see your answer written y equals 3. You do not need to show the 0x term if the slope is 0. So the fact that the tangent line is y equals 3 tells us it's a flat horizontal line. The tangent at that point is horizontal. That's because it must be a maximum or minimum point, or an inflection point, where the slope is nothing. Slope is 0. All right, and the last part says, write down the coordinates of the second point where this tangent is going to intersect the graph. So we're looking for another place where y equals 3 intersects this graph. So the line y equals 3, I think I would go to a calculator for this. Adding myself a calculator page, not a calculator, graph page, typing in the function 5 x to the third power minus 3x to the fifth power. Notice I am typing in the original function. I don't want to graph the derivative function pretty much ever for this. This one looks funky because it's only showing on the test this domain. I'm going to go change my window so I'm also only seeing that domain. It'll make it a little bit easier to see. I'm going to make this negative 1.5 and make this positive 1.5. There, now it looks just like the one I see on the test. I'm going to also graph the line y equals 3 right on the same screen. And now I can see that the green line intersects the red curve all the way on here on the right, and that was at 0.13, and intersects it also all the way on the left. I'm going to find that intersection point. Going to Menu, Analyze Graph, Intersection, number 4. Click on the left of it, click on the right of it. It finds that intersection point for me. Negative 1.38, 3, and it does ask for coordinates for this question. So the coordinates would be negative 1.38, 3. And the final question on paper 1. We have a cost function and an income function given to us, and it's asking us first to find p of x, the profit function. Profit is always your income minus your costs. That tells you what the profit is that you get to walk away with. So for your profit function, you want to do your income function Notice I'm putting it in parentheses, minus your cost function. Absolute most common mistake for this is forgetting to distribute the minus sign that you just put in front of that cost function. When you do this correctly, slide this up a little so I have some room, it'll end up being 150x minus 0.6x squared minus 2600 minus 0.4x squared, because you are distributing that minus sign. You're subtracting the whole cost function, each part of it. Then you simplify by combining like terms, and the correct final answer for part A, move this up again, correct final answer for part A, negative 1x to the second power plus 150x, that should be positive, minus 2600, just 2600. Okay, so here's my final function for profit. Part B, find the number of machines that should be made and sold each month to maximize P of X. Asking me to find a number of machines, which means find X, when P of X is a maximum. Going to use a calculator for this. All right, number of machines at the maximum point. Go and graph this thing. Negative x squared plus 150x minus 2600. It's off the graph because when I hit enter I don't see anything. I'm going to change my window. Let's make our y minimums much bigger so we can see if we can start getting a glimpse of this thing. All right, I see part of it now. It's almost looking like a straight line. Tells me I'm going to want to change my x values a little bit because I'm looking at too limited of a number. Okay, I'm starting to see more. I see where it's rising up to a maximum there. But I need to see higher. So let's go to my window and make my y maximum also higher. Okay, we're almost there. So we're looking for that maximum point that's up there at the top that we can't see. Change it just a little higher. And hope this is good enough. All right, cool. Now I can see that maximum point. Then we go to menu, then we go to analyze graph, going to find a maximum, click on the left, click on the right. It tells me that the maximum is 75, comma, some large number for profit. It's written scientific notation, but it's not asking me for the profit right now. It's asking me for the number of machines I would need to get that profit, and the number of machines is an X value. So it's pretty clear that the number of machines that I would need to make is 75 machines. And then the last part, use your answer to part B to find the selling price of each machine in order to maximize P of X. This is the only part of this that you really need to do some thinking. To find the selling price of each machine, you think about your income, right? The income that you're getting is only from machines being sold. So if you're making 75 machines, your income can be found by doing the income of 75, or plugging 75 into the income part of your function, and evaluating that on a calculator. This is going to tell us what our total income is. 150 times 75 minus 0.6 times 75 squared. 78.75 is our total income when we sell 75 machines. 75 is that sweet spot that maximizes profit for us. So that's the number of machines that we want to sell. So if our total income has to be 78.75 and we're selling 75 machines, when we divide this by 75, it should give us the rate that we need to charge for each machine. So this divided by 75 would equal 105. Does it say what units? Or money? Yeah, that says dollars. $105 is how much we need to charge for each machine in order to get that maximum profit point that we were looking for. Okay, and that is the end of paper 1.